All right, we'll go ahead and get started. My name is Nicole Lucas. I'm hosting the event, but I will pass it off to our speakers shortly. Just a heads up for logistics for everybody. We're going to have the presentation and then there will be time for Q&A afterwards. So anyone who has questions, please use the Q&A button at the bottom of your screen to type in your questions, and we'll get to those at the end. If you have any issues with sound or anything, you can use the chat feature, and I can work with you to hopefully get that sorted if you have any other non-presentation related questions. And I think that should pretty much take care of it. So I will pass it on to Connor to introduce himself.
Hey everybody, yeah, I'm Connor. I've been with Seabird since 2019, and I'm very excited to show you guys our discussion on the SeaFOx V2.
Hi everyone, my name's Iram Rahman. I've been with Seabird since the end of 2019, and I'm really excited for you guys to watch our presentation and interact with us today. Thank you.
We will go ahead and get started.
Hi, I'm Connor Bacon, and I'm here with Seabird University to tell you about the Deep SeapHOx V2, our moored real-time salinity-corrected pH system. We'll begin by looking at a physical overview of the Deep SeapHOx V2. We'll then look at the battery endurance of this whole system, and then we'll look at the software and data processing side. And then after that, we'll look at the integration of the SeaFET V2 and 37 SMP ODO, as well as wrapping up with common issues and troubleshooting. Once you've removed the top 6 screws from your crate, you'll find either your service or order documentation along with your calibration sheets, your pigtailed test cable, your computer serial data I/O with pigtailed cable, the universal spares kit with O-rings, and the Deep SeapHOx spares kit. And finally, your AA lithium cells kit. So the Deep SeapHOx V2 is a multi-sensor system, so we'll begin by looking at the Deep SeaFET V2. The Deep SeaFET V2 is connected to the Y cable, which is a 8-pin male and CBH connector. Both ends of the Y cable on this side are 8-pin male, and that will connect to your PC via your 8-pin MCBH to serial RS-232 connector, as well as a pigtailed power supply cable. The Deep SeaFET V2 uses the SeaFET pH sensor technology, which is an internal reference and an external reference, which both give separate reference potentials to the SeaFET and show separate pH values. For long-term storage, we recommend that you store the electrode dry. However, for long-term storage, we recommend that you use filtered, pure seawater. It's also generally recommended for all of our products, including the SeaFET V2 and Deep SeapHOx V2, that you calibrate the system annually. The 37 SMP ODO comes outfitted with a conductivity, pressure, temperature, and 63 oxygen sensor. There's also an integrated pump, which is controlled via the adaptive pump control setting, your minimum conductivity frequency setting, and the pulled or periodic mode. The system also has a replaceable battery pack, which is complete with 12 AA lithium cells in a removable battery holder. You can find more information about those specs in the manual. The Deep SeapHOx generally has a 5,000, 7,000, or 350 meter depth rating. we recommend that all sensors are calibrated within 1 year of their purchase or previous service. This Deep SeapHOx V2 system has 2 sets of internal batteries, both in the SeaFET V2 and in the MicroCat. These batteries are run independent of each other, but both should have their individual endurance calculated prior to deployment. You can do that using our software, such as UCI's deployment software, as well as the battery endurance calculator, which is part of the CSoft package for the 37. The input power when powering externally will go through the SeaFET V2, which then powers the entire system, 37 and SeaFET. You'd want to have at least 9 volts of external power applied, as that is the logic for the internal circuit. If that voltage drops below 9 volts, it will default back to the 12-volt battery pack inside of the SeaFET.
The UCI software has been developed by Seabird for use with many different instruments over the years and has been adopted as the primary software for the SeaFOx V2 system. This all-in-one software package allows you to set up your Deep SeapHOx for deployment, send commands via terminal, and visualize and export collected data. In the next few slides, I'll walk you through some of the powerful tools available to you in our software. UCI is the primary software for connecting to your SeaFOx and preparing it for deployment. Since the SeaFOx system uses the SeaFET component as the primary controller, you should always have a copy of UCI available for a clean and easy deployment process. For communicating directly with the 37, other software can be used, which I will explain later. I'll demonstrate some of the features of UCI, such as checking your settings, the deployment wizard, and data visualization. Once you've opened up UCI, hit Connect. Under Instrument Type, make sure you've selected SeaFET and check that your baud rate is set to 19200. Once it's finished with its transition, it should show connected. Perfect. Under Connection Mode, it'll show a green Setup tab. Let's first check the instrument settings. Here you can see the current output format, as well as the sample interval, baud rate, pump duration, and whether or not you want to power the 37 ODO. I'll click Yes. Hit Apply, and it should save. Before we get into the deployment wizard, there's a couple other good places to look and know about. First, the command terminal. Here, you can choose from a drop-down menu to see many different potential commands, including DS, and get CC, which shows your calibration information. The other useful option from the SeaFET dashboard is transfer data, which allows you to visualize your data that's been saved to your instrument memory. After some quick setup, all the defaults should work, and it'll upload your Deep SeapHOx's data. Hit transfer, and you're way to go. As you can see here, it'll show graphs of a time series of a bunch of different options. You can zoom in, zoom out, and auto range using right-click menu. Now let's get into the deployment wizard. First, you're going to want to choose what operating mode you're using, autonomous or pulled. The descriptions are both given in case you aren't sure which you want to use. Generally, we recommend that you synchronize your SeaFET clock. In this case, I have not done so, and you can see the discrepancy here. I'll move on for now, since it's not pertinent to the discussion at hand. Double check your output format. Double check that your pumping duration that we saw earlier is correct. And enter in your minimum deployment temperature. This is for the deployment endurance. So for this example, we'll use 1 degree Celsius. The polling interval that we're using is 600 seconds. So we can see our battery endurance is 285 days. Hit next, and it'll give you the option to enter in some deployment report settings, such as your name, comments, and where you want to upload the file to. When you hit finish, it will store your settings, disconnect the instrument, and generate the deployment report. The SeaFOx system uses the salinity and temperature values recorded by the 37 SMP in order to output corrected pH values. These values are contained in an SBS DAT file, which can be visualized in UCI as seen earlier using the transfer data function. You cannot use the SeaFET processing tab in UCI with the SeaFOX's data, as that is primarily meant for salinity correction, which is done automatically by the SeaFOX. If you do run into issues during deployment with your microcat, we recommend that you reach out to support directly to discuss your options. Once you've finished transferring your data, go to Data and Export Log Data. Search for your file here. As you can see, it's shown up as an SBS DAT file. Select your file, hit Open. Hit Next. Check that the output format is what you want. You can also just change your oxygen here. Choose which export option you want, whether it's an Excel workbook or as a CSV file, and hit Finish. And there you go. The UCI terminal is a powerful tool to help you communicate with your Deep SeapHOx system. It is a simple terminal program that lists many of the useful commands available to your SeaFOX without needing to choose things like baud rates or COM port settings. For most users, the setup wizard and the terminal should be all you need for your first deployment. You can access it by clicking the button on the SeaFET dashboard or by navigating to Sensor, SeaFET, Command Terminal, which will open a new window. The instrument will respond immediately to all commands when not sampling. For instance, getCC will display your system's calibration coefficients, and DS will show your instrument's information and status. Some commands are not shown in the drop-down menu and can be found in the Deep SeapHOx V2 manual and the latest version of the 37 SMP ODO manual. For any command meant specifically for the 37 SMP ODO, you will need to add the prefix send37 equals. The terminal is not required for every deployment, but can be helpful for changing settings without using the deployment wizard or for troubleshooting.
The Deep SeapHOx V2 is a combination of the SeaFET V2 and the 37 SMPODO. Their physical connection is managed by two main brackets as well as the plumbing between the two sensors. The electrical connection is handled by a Y cable. This side connects to your PC, and each of these two ends are both have specific pin outputs that can't be mixed up. The flow path of the sensor can be found here. The inlet draws in water using the pump, pumps the water up the conductivity cell through the temperature and pressure sensor, and finally to the dissolved oxygen sensor. It takes a loop here, goes back down, and then traces back up through the SeaFET pH sensor, and then is finally ejected out of the outlet tube here. Please be sure to remove the sticker before deployment so as to not prevent water from entering the inlet tube, but maintain the steel during storage so that the antifoulants installed do not dry out.
There are some questions that get reported to our team more often than others, so we've captured a few of them to discuss here. First, your data upload keeps freezing. The first option is to try another RS-232 serial adapter. We have a recommended one listed here that oftentimes does help fix issues in the data upload process. Another option is to try to download your data in smaller chunks. This can be very helpful in larger deployments when you have a lot of data upload at once. And finally, if CTerm V2 isn't working for you, use TerraTerm or other terminal program to offload the data. Next, if you're not receiving pH values, check to see if you're collecting salinity and temperature values from your 37. Without it, the pH values will not be generated. The best way to do this is to connect directly with your microcat in CTerm and try to communicate with the instrument as well as take samples. If all else fails, test or replace the cable which connects the SeaFET to the 37 for continuity. Finally, if you're getting unreasonable data from your microcat, make sure the calibration coefficients are entered correctly in the microcat memory. Use the send37 equals getCC command in terminal to see the response and compare that output values to your calibration sheets. If you ever have questions about your data or with our software, reach out to us directly and we will be happy to get you back on track.
I think we can hop into the Q&A. If you have questions, please type them into the Q&A section and we will get to them. So the first one we have is from Tanya. How much time would count as long-term storage when you would recommend the SeaFET be stored with filtered seawater in the cap?
Well, I think the first thing to point out is you don't want the SeaFET's external reference to be dry for really as much time as possible. Let's see a little. Okay, I'd like to answer this question live. Yes. So yeah, as I said, you want this to be stored with a filtered artificial real seawater. If you can manage that to help maintain the DuraFET. If you don't do that, you're likely going to see drift fairly quickly. Our recommendation in the manual is immediately. So as far as for long term, it's neither here nor there. I'd say it's for any amount of storage. You should use that filtered real seawater. Nice to see you as well, Aaron. Long time no see. Yeah, I think so. Some of the specifics as to what salinity correction is done is likely covered more clearly in the manual. But when we're talking about the integration between the 37 SMPODO and the SeaFET, obviously the pH calculation that gets used by the SeaFET uses a salinity component, And by having the real-time connection to the 37, which itself calculates salinity based on its recordings of conductivity, pressure, and temperature, that data stream allows it so that the SeaFET, which will sample a bit slower than the 37 can on its own, every time you get it pulls a sample, the SeaFET will pull a sample from the 37. It takes that calculated salinity, adds that to its own equation, and then essentially puts out the best accurate data that we can provide. It's hard to say specifically what changes in the correction, given that really what we're doing here is using the real-time salinity values generated by the 37 to get the best accuracy on our SeaFET, that normally on a standalone would just use values that you'd input earlier on, or at a later stage in the data, excuse me.
And our next question is, can we integrate the SeaFET locally if a customer has an SPE 37 SMP, SPE 37 SMP ODO?
Do you want to take that one, Iram?
Yeah, I believe for now we're doing that on a case-by-case basis. Am I correct, Connor?
Yeah, we generally recommend that you send it in. And also just to call out, the SMP ODO, because it has that oxygen component, is required for the SeaFOx integration. And I do believe there's some ways to have them connect and pull each other, but it requires the right firmware to work.
Yeah.
And that ODO is required. So
there's a lot of firmware, there's commands for the integration. So it's kind of complicated, and we're doing it on a case-by-case basis.
Yeah, so if you are interested in having that upgrade done, or if you have both of the SeaFET V2 and 37 SMP ODO, I definitely suggest you reach out to our service team to get an RMA started, and they can do that process for you. Do you have oh, sorry, don't want to take away your job, Nicole.
Oh, no, you're fine. The next question we have is also from Aaron. Do you have recommendations for reducing biofouling on the inlet? Is the conductivity cell safe to flush with fresh water as it is with the 4C?
Yes, you can use fresh water. Typically, we'd go with DI water if you can. It's very similar to a lot of our glass conductivity cells. I wouldn't directly compare it to a 4C, but it's a microcat conductivity cell. The reducing biofouling on the inlet specifically. So once the system's been set up properly, there will be an antifoulant tablet inside of the plumbing, right on the inside of the inlet, just a couple millimeters in. But if you're noticing things like biogrowth, algal growth, barnacles even on the outside near that cell guard, I've seen people use copper tape. Really, your mileage may vary with that, but generally copper is a good way to do external fouling. But on the inside, making sure that you're getting your instrument serviced every year, that will help us renew the antifoulant tablets inside of your unit. You can also do that yourself by removing the cell guard and replacing the tablets. I believe we currently still sell those on a case-by-case basis for our pumped CTDs. But as far as that goes, yeah, so making sure that your TBTO packet is still fresh and potentially using some more inventive methods on the outside, like copper tape. Do you have anything to add to that, Iram?
Yes, I believe you got it all. Thank you.
Approximately how long can the SeaFOx be deployed unattended, and any recommendations?
Yeah, so maybe you want to start, Iram?
Well, in general, we recommend not deploying it really past a year or a little bit more than a year. I guess I'm just struggling to understand what you mean by unattended, like just leaving it there.
Yeah, so what I'm interpreting here is potentially a mooring where you have it hooked up to a data logger or it's running autonomously and just collecting that data. Either one of those situations, I'd really defer to what kind of sampling structure you're going to be using. Refer to your, and I apologize for the video quality. It does show up in the video I took, but there's a pre-deployment calculation for how long the system will be able to run based on your deployment temperature and sampling structure. So if you use that as a general recommendation, I believe I use 600-second interval, gave me 283 days. Always stick to that as far as leaving it unattended. If there's any way for you to check in on it periodically, if you're in an area with a lot of fouling or a lot of sediment flow, potentially, there's always a chance with pumped CTDs that they get clogged with sediment if you're in a really, really high sediment area. They are designed in a way to help reduce that effect, as well as they have, like I said, they have got that anti-foulant cartridge to help prevent fouling internally. But the longer they go out, and if it's in an area that hey, I'm right at the mouth of a river and right, really close to the bottom of an area with high bed flow, you're going to want to check in on that. Maybe there's no real recommendation here, but I'd say every 6 months.
See if anyone has any other questions. You can go ahead and put them in the Q&A section. Give it another minute or so.
I'll bring up one I usually get a lot of that I didn't add to our slide here. So some people question the difference between using artificial seawater and real filtered seawater. And I times in one of my earlier questions, it is important to use real seawater. It's very difficult for artificial seawater to match the ionic composition in such a way that it does not cause drift in the instrument. So if you're able to source filtered seawater, that's absolutely ideal. If not, reach out to us because it's strongly a case-by-case basis. We do have an FAQ up on our website about this that goes into it with some great detail. So I will refer you there, but just want to make that disclaimer.
Thanks, Connor. We got one more question. Can the anti-fouling copper guard be purchased separately to fix it to the existing SeaFET?
As far as I know, it's not specifically designed for it would be for the 37 SMP ODO. And Iram, maybe unless you know of it, I don't know if it's specifically tailored to just that connection. We can look into that for you though, if you reach out to us and our sales team about the options. For those who haven't reached out to us before, our email is support@seabird.com or techsupport@seabird.com. Both work, and you'll get a response within 24 hours.
All right, I put those emails in the chat, and everyone will also get a follow-up email after this webinar that has my email. So if you have other questions, if you think of something, feel free to reach out and I can direct it to Connor or Iram or whoever is the best contact for that. Looks like we don't have any more questions coming in. So thank you, Connor. Thank you, Iram. And thanks everyone for bearing with the video issues. As I mentioned, this will be available online soon after the webinar, so you can revisit it if you like. But thanks, everybody.